Hello, everyone. Welcome back. So this is the third check or understanding, which would be a word problem on page 563. However, before doing that, I'd like to begin by doing an introduction to distance, speed, and time problems. So take a look at what I have for you. So this is an introduction to word problems involving distance, speed, and time. How many of you have seen this before? This one. Okay. I remember when I was in school, that is sort of a graphic that my physics teacher gave to us, which my math teachers also decided to adapt. Or and I think in St. Pat's, from what I heard, um, some of the physics teachers also use this. So what it's saying is the connection between distance, speed, and time is that the distance will be equal to speed times time. All right. Meaning, if you're trying to find the distance and you're given speed and time, you will multiply speed and time to get the distance. Or if you're going to be looking for the speed, you will, and you are given distance and time, to find the speed, you will be dividing distance by the time. Or if you're going to be looking for the time, if you're given the distance and the speed, you will divide the distance by the speed. And I have all three examples here. So suppose it takes you 2 hours to walk a hiking trail and your speed is 5 kilometers per hour. How long is the trail? So as I was saying, distance is equal to speed times time. So really, look at the speed that you have, 5 kilometers per hour, which is really 5 per 1 hour. So that means it can be written like this as a fraction, 5 kilometers over 1 hour times 2 hours. So when you do this, you will see that the word hour cancels out, leaving you with just 5 times 2, which gives you 10. That's where the 10 kilometers comes from. Okay. Obviously, if you're walking 5 kilometers per hour, it takes you 2 hours. So that means you would have covered 10 kilometers. Okay. Let's take another example. Suppose it takes you 2 hours to walk a 10-kilometer trail. What is your walking speed? So I just sort of manipulated the previous example. This time, we are talking about the number of hours it takes to walk the trail, which is 10 kilometers. What is the speed? So if distance is equal to speed times time, therefore, speed is equal to distance divided by time. So the distance that was covered was 2 kilometers, all right, or 10 kilometers, sorry. And the time it took was 2 hours. So right here. So 10 kilometers divided by 2 hours. It is, so these two cancels out. This is a 5, this is a 1. So really, it would be 5 kilometers over 1 hour. Although you don't really, you're used to writing it this way, 5 kilometers per hour. All right. You don't really write per 1 hour. Another example. So suppose you are on a 10-kilometer trail and you are walking at a speed of 5 kilometers per hour. How long will it take you to finish the hike? So this time it is the time that we are looking for. All right. How long will it take you? There you go. To finish the hike. Okay. So time is equal to distance divided by speed. So what is the distance? 10 kilometers. You will divide that by the speed, 5 kilometers per hour. So take a look. So the distance is 10 kilometers. You will divide that, okay, by 5 kilometers per hour. Now look, to do the math properly here, the 10 kilometers will be divided by a fraction. The fraction here is 5 kilometers per 1 hour. So to divide by a fraction, it is the same as multiplying by the reciprocal. That's why in the next step, this is what I have. So the numerator here, I just copied. If I'm dividing it by this fraction, I will flip the fraction. So look, it was flipped. Instead of dividing, I turn it to multiplication. So now I can simplify. Kilometer word cancels out. 10 cancels out to the 5. There's a 2. 2 times 1 is 2 hours. There we go. Okay, so I think I've given you a sort of an brief uh, preview or intro to what we will be doing. It is important that you understand or you have any, you're able to recall the idea of distance, speed, and time as we go to the next check understanding. Here we go. On a canoe trip, the paddled upstream a distance of 10 kilometers. On the return trip downstream, the average speed of the canoe was 5 kilometers per hour greater than its speed upstream. So I will stop there for a while. So there's this guy who was paddling upstream a distance of 10 kilometers. All right. So on the return trip downstream, the average speed of the canoe was 5 kilometers per hour greater than the speed upstream. Now, if you're understanding what this is saying, if you're thinking, why is it that the speed of the canoe was 5 kilometers per hour greater when it was going downstream? Well, ask yourself, isn't it going to be faster when you are going with the current as opposed to going against the current? All right. So in math, the idea is um, the speed of the current is actually going to be added to your speed if you're going with the current, and the speed of the current will be going against so will be subtracted from your speed if you're going against the current. Anyway, that is something we're going to talk about when we solve rational equations. But for now, I just wanted to give you an idea of what it means when you, or what impact it has when you are going upstream um, as opposed to going downstream. Again, going upstream means you're going against the current, so it will be slower. If you're going downstream, you're going with the current, so it will be faster. That's why it is 5 kilometers per hour faster than it was going upstream. So we are to write and then simplify an expression for Petan's total paddling time in terms of the average speed upstream. I didn't really like the way they wrote this, okay, because it's sort of confusing. What it actually says is this. So how long was the total time it took for Patan to go upstream and downstream? It was a total time, all right? So like total travel time, if you get what I mean. So that means the expression we need to come up with was for the distance going upstream and downstream. All right. So let us begin by saying that x is Patan's speed upstream. Okay, because we don't know how his speed. All right. Um, so if we are going to be doing this, I strongly recommend making a table. All right, like this. So as we go into solving rational equations, I really recommend doing this one because I just feel that it is easier, but I have seen kids do it a different way. They don't want a table, and it's really up to you. Okay, again, as long as the math is correct, and I'm fine with that. I'm just used to doing it this way. So, um, so as we fill this out, so we already have defined our variable x to be Patan's speed upstream. So as we slowly fill out this table, all right, so let's look at what expressions we're going to be using. So D stands for distance. So what is the distance upstream? Well, it says here the upstream distance was 10 kilometers. So this is a 10. All right. Now, what is the distance downstream? Well, it was the same distance because it was the same um, trip that he took, although he just went upstream and then downstream. So this is also a 10. So what was the speed upstream? Well, we already defined it as x. All right, so this is x. So if his speed upstream was x and the speed downstream, all right, was 5 kilometers per hour greater than the speed upstream, it would have been x plus 5 here. Oh, by the way, this is in um, kilometers per hour. In kilometers per hour. Okay. So, well, how long would it take, or would it have taken this person to cover that distance? Well, if the distance is 10 and the speed was x, that means distance divided by speed would be 10 over x. So the time it took for Patan to um, go upstream was 10 divided by x. All right. What about downstream? All right. It would have been, it would have taken 10 divided by x plus 5. All right. That is what it's going to be. So, what is the total paddling time? Well, the total time that he took would be going upstream plus going downstream. So just add those two. So total paddling time would be to put them together. All right. Oh, by the way, since our x is talking about um, speed and that it's in real life, we already know that our x has to be greater than zero. Okay. Okay. So the total paddling time would be 10 over x plus 10 over x plus 5. Okay. And then let's just simplify that. So to be able to do this, let's have the same denominator. So just multiply this and this. So again, just like what I've been doing from the beginning, if this is the original fraction that I have for the first one, I will need this to be multiplied to the denominator, which means I also have to multiply it to the one on top. All right. Now, the, oops, the next one, I originally had 10 over x plus 5 only. All right. But since I need to multiply it by this one, so the denominator is what I'm referring to, I need to multiply this by x, so the top gets to be multiplied by x as well. And then let's simplify. 10x plus 50, and then plus 10x. Now this is the result of this one. This is the result of this one. All right. So I'm just going to put them all together and in the same denominator now. It is entirely up to you if you want to make it x squared plus 5x for the bottom. 10x plus 10x is 20x plus 50 over x times x plus 5. So there is your expression, which would represent the total paddling time, okay? The total paddling time in hours, all right? Okay, there is your expression for it. And again, x is greater than 0, okay? All right, that's it for me. Kindly do the homework. After the homework, I will see you and then I will tell you what we will be doing for the rest of the block. Thanks for watching. Bye.